So we got step number 2. Let's roll on to number 3. We now must multiply each particular fraction, each rational expression, by what is missing from my common denominator, comparing it to each of the individual denominators. Heh, well, here's what it means. 2 times 3 is the same as 6. Wait a minute. That's what I have in this one, so I don't need to do anything with this particular one. I have what I need. I have my common denominator in that one. I have 6. What I need, though, in this one, that's not 6. So what am I missing comparing 2 to my common denominator? Well, I'm missing a multiplication of a 3. So therefore, I must multiply by a funky-looking 1. So I multiply the top and the bottom by 3. Why? Because I'm missing a 3 in my denominator. I have a 2, but I'm missing a 3. So I must multiply this to get to my 6. Oh, that's what I do. So when I multiply the tops, I get 3. Sweet. That's parallel example over here to the right. Well, my common denominator is this. Check this out. I have that one. So this one is good to go. I don't need to do anything with it. Over here, however, I am missing something comparing this denominator to my common denominator. I'm actually missing an x minus 1. So I must multiply the top and the bottom by what is missing. Because then when I multiply the denominators, I get exactly this right here. I get my common denominator that I need to be able to have both of these the same to continue the question. So what I do, I multiply this 1. I actually distribute it to the x and the negative 1. This doesn't really apply so much in this question. It doesn't affect it much. But if this is a 3 or an x squared or 2x, it would majorly affect it when you distribute it through there. Regardless, x minus 1 is what it becomes here. So there, ladies and gentlemen, is number 3. So now we just kind of add some things, clean it up if we need to. Since my denominators are the same, I add across the top. 5 plus 3 gives me 8. Denominators stay the same. That's step number 5. Step number 6, simplify this, and I could, down to 4 over 3. Sweetness. Let's go over to this one. Denominators stay the same. Across the actual numerators, I must add them. So x plus x, they're my like terms. That's why I get 2x. Negative 1, there's nothing else to subtract a negative 1. And then I can kind of look at this as step number 6 and say, wait, can I simplify this anymore? Can I maybe factor out a common factor or do something? In this case, that's a binomial. It is the difference, but these things are not, it's not the difference of 2 squares. So that right there, ladies and gentlemen, is my final answer. On to another example. Well, we're adding here, and have you noticed? Oh no, we don't have common denominators. X plus 4, x squared minus 16. Well, let's do it. Let's get common denominators. Okay, step number 1, factor. Well, this one's already factored. There's nothing else I can do. This one, oh yeah, it's the difference of 2 squares. So I factor this into x plus 4, x minus 4. So that's factored nicely. That's factored nicely. Let's now construct our common denominator. So what I do is I'll start with this one. I know I'm going to need an x plus 4 in my common denominator, because if it's in this denominator, it's got to be in my common denominator. Over here, I have an x plus 4. Sweet, that's matched up. We're all good. But I am needing also an x minus 4. Because it's in this denominator, it must be in my overall bigger common denominator. So this needs to go here too. So I have x plus 4 and x minus 4. So if you take this common denominator and cover this, they're both covered. Good. I take this common denominator and put it over here. That one's covered with that. So we're all good to go. So now we got to go into step number 3 and figure out what is missing. Now listen, the denominators aren't the same, so there's obviously going to be something missing. You just got to figure out what it is. And that's when you use this. So if you look at this second one over here, oh boy, look at here. Well, I have x plus 4, x minus 4 in my denominator of this rational expression. That's exactly the same as my common denominator. So I'm not missing anything. Therefore, this rational expression is perfect. We put it right down there, and we're good to go. Over here, however, oh no, I have x plus 4, so I'm obviously missing something comparing it to my common denominator. I have an x plus 4, sweet. What I'm missing is the x minus 4. So I need to multiply the top and the bottom by what's missing, the x minus 4. The trick here is doing this. When you do that, you got to make sure you take this 3 or whatever's up here and distribute it to this binomial. That's a key thing right there. So you take the 3 times the x, you get 3x. 3 times the negative 4, you get negative 12. Wonderful. Now if you notice, x minus 4 times x plus 4 gives you exactly this, which is your common denominator. Sweet. So now I have these two guys, exactly the same denominators. So I've got what I need. Now I just got to get the answer and be done. So, step number 4. I'll add across the top. I got some like terms. 3x plus an x gives me 4x. Negative 12 plus nothing gives me negative 12. My denominators, remember now, step 5 stays exactly the same. In step 6, if I can do it, which apparently I can on this one, I can look at the top and say, ooh, I can take the top part here and factor out a GCF. Factor out the 4, which gives me x minus 3 in the top, so 4 times x minus 3, and then the denominator stays exactly as is. So there is my final answer. There's nothing I can cross off. I can't cross off this 4 and that 4, because remember, it's grouped together, and so is that 4 and that binomial. So I can't do it. Likewise, I can't cross off the x's. So there you go. That is an addition. We haven't done one of these yet, but we're going to do it now. Let's do a subtraction example. So here we go. Okay. I'm going to have this completely blank for you. What I want you to do is, really my recommendation would be, pause the video right now. Pause it, do this entire question, and see if you get the question right. I'm going to do it now though, but pause it. That would be cool. So here we go. Well, notice, oh my, I don't have common denominators, so I must do it. Let's factor these things first. Xbox method would tell me I get x minus 6, x plus 5. So that's factored right there into those two factors. X plus 5 is just going to stay x plus 5. Lovely. There's step 1. Step number 2. What I would do is construct my common denominator. Well, here's how I do it. I look and say, well, I have this x plus 5. I know that's got to be in there. Over here, I have the x plus 5, but I'm missing an x minus 6. Okay. So x minus 6 is there. So I have everything covered from these two denominators. If I take my common denominator, check, they're both covered, and check, that one's covered. So I've got what I need in my common denominator. So now I got to look and say, okay, what is missing? Well, in this one, my denominator is that. That's the same as my common denominator. So I'm good to go. X over x plus 5 times x minus 6. That one I don't need to change at all. We're good to go. I'm going to put subtraction down, and then over here to the right. Well, for this one, am I missing anything in my denominator of this rational expression, comparing it to my common denominator? I see it too. Good job. We are missing something. What are we missing? We're missing this guy. It has an x plus 5, but it doesn't have an x minus 6. That's the missing piece. So we'll multiply the top and the bottom by x minus 6. Lovely. So now when I do that, in my denominator of this one, I'm going to have x plus 5 times x minus 6. And that's what I wanted, because now I have common denominators. Now on the top, well, again, this is kind of a simpler one. I take the 1 times the x and the 1 times the 6, which gives me just x minus 6. So there we go. I've got common denominators. Now I can do step number 4 and subtract the numerators. Now this is where you got to be careful. I hope you write this down. When you subtract these bad boys, this is really what you're doing. You're taking this. I'm going to come up here so you can see it. I'm going to take the numerators and write it this way. X minus this whole stuff right there. I'm putting it in parentheses. So it's x minus whatever's over here. If it's a whole binomial, trinomial, whatever, it's got to be subtracted, that whole thing. Yep, there's a reason why I put parentheses around it, because you got it. We got to distribute that subtraction sign through there like we did many moons ago in another section. So I must take this, distribute it, which actually gives me x plus negative x, if you will, plus 6. All of that over x plus 5, x minus 6. That's the same denominator carried through. And now I just keep on cleaning up and figure, oh wait, x minus x is just later. That's gone. So I'm just left with a 6 on the top. So I get 6 over x plus 5, x minus 6. Am I done? Wait, the 6, nope. Can't cross them off because that's grouped together right there. So I can't do it. So ladies and gentlemen, welcome to your first mega subtraction rational expression question. Here we go. Let's practice these questions in class. Later.